Hello everyone, welcome to my advanced operating systems visual demonstration. So what I'm going to present now is the VectorClock um, that is used which is the third exercise in this laboratory series. So here I'm going to execute some codes as to what is VectorClock and how it is as to how what's the underlying principle and how we are executing this code and how we're getting this output. So what we are trying to do is that here we are looking at a vector clock. We are visualizing it in this way. So here is the dissemination of the time in vector clocks, a space versus time versus space diagram, and here we have three processes, and the events in each processes are organized in its vector form. So you can take it as x, y, z, and subsequent events having the same format. So what they do here is they are just passing messages from this event to the other, and that is what we are going. That is one instance as to what we are going to show in this program. So likewise, right now what I'm doing is I'm limiting the number of processes and the events to less than 3. So that it can, I can finish showing you the output quick enough. So I'm going to run this program right now. So and before running this program, I'd like to show you my the gist of what the exercise is about. So so this is vector logical clock, and this is what it is. The two implementation rules are as follows. That is Ci of I equals Ci of d plus d. Here the clock Ci needs to be incremented for a process Pi. So that's the drill, and that is how we go about. And so moving on, for any k, Cj of k equals max. We are just computing the max from the maximum of the values over here. And the algorithm begins like this. It begins and then increments the counter for timestamping any event. Then the vector is compared using the timestamp vector, and then moving on with the loop. We are moving on forward in a loop. If it is received, then the system equals received. If it's concurrent, then the concurrent function executes itself, and then it computes whether the vectors passed on in a program are concurrent or not concurrent. So likewise, this is the program code. It has the function inputs, and we have we are taking in the inputs as well for the number of processes, and in the events and the messages. So as we just go down, here we are just calling it from the main function, and it just in this, what you see in this program block is what you see that we are using the program codes for. So likewise, this is the program, the entire code in it. We are using certain operations to compute and pass the messages and timestamping from the source to destination. So let's go ahead with the program and let's execute it and see what's happening. So I'm here. Okay. So Java, I think I've typed it earlier. Java vector. Okay, enter the number of processes. I'm entering 2. So enter the number of events for process 1. I'm entering 3. And for P2, I'm entering it as 3. And the number of messages, I'm entering it as 2. For the first source, I'm entering it as 1. For second source, for the first destination, I'm entering it as 2. Second source, it's 3, and second destination is 2. So having entered these values, you need to visualize as to what I showed you in this diagram. So I've limited it to the first 2 processes, this and this right here, and I've put as to these requirements, I've put 3 events each, 3 and 3. So here 3 and over here 3, not 4. 3 events each, and then I have entered the message to be passed on from the first to the second event and the third to the second event. So that's what I did, and let's see what happens after executing. Okay, so here's the output. What's printed over here is process 1, so events TS 11, 1, 0, 12 to 13, 3, and so on and so forth. That's what I did. So that's what the output is, and that's what's getting printed. So these are the timestamp values. So and they are compared for, and they are incremented, and these are the values that's being printed. So here we are. That's the output, and I hope you understood it. There are more videos to come. Thank you for listening to this video demonstration. Thank you very much.